Okay, so I'm starting off on the Living Atlas website page. Really, the Living Atlas is a subset of everything in ArcGIS Online. As Jack mentioned, there's millions, I think over 29 million items in ArcGIS Online today, and it's being hosted as a combination of things that Esri might build and serve, or it might be a specific user. You know, you think of a NOAA, even a Santa Barbara, you probably have layers of information in ArcGIS Online that can become available. The Living Atlas is a way for you to elevate your authoritative content and get access to these large data sets from trusted repositories. And if I go to the Living Atlas website here, what I'm doing is just show you the sort of lead page. It's talking about things that are going on, what's new and what's been added in the last few weeks. It's got longer term projects that are going on, like, you know, COVID is a consistently updated data set. We work with John Hopkins and manage the dashboard for them behind the scenes, and really do that every hour update of the system to make the dashboard available. We have areas where we talk about biodiversity. Jack was talking about the Half Earth project. I might be able to do a demo of some upcoming work there. And then this indicators, and these are all applications that are sitting on top of this live content. Um, the content itself can be either browsed. If we go over here, we can look at the full collection. We've sort of categorized everything into larger buckets that work well for our curation team. So for each one of these groups, we have somewhere between 1 and 4 curators who, if somebody nominates a layer, let's say this layer on hurricanes, it goes through a curation review process, and there's 2 levels to that. One is a quantitative review. So we actually look at all the metadata and analyze it for completeness. So does it have fully described information? Does it have aliases? Does it have URLs to people for emails and contacts? Is the data being maintained and current, or is it the most current available? So we can do all that sort of in a quantitative view and score every item. Once we've done that, a person can then ask for their layer to be added to the Living Atlas. And that turns into more of a quantitative review. So it goes to one of these curators, and these curators sort of interact with the team and look at the next level things, things that you really can't quantify. How good is a pop-up, or how good is the performance? So we look at those kind of things and iterate with the users until it's really ready to be shared with everyone. And then we bring it live and into the Living Atlas. You could tell today there's a little under 9,000 items. There's new items added probably every day, and in some cases we're retiring older ones. You know, some things are very timely in nature because it's not just data. It might have story maps or learn lessons or a combination of things, but you know, an old story map that may have been really interesting and exciting to the user base around the Olympics, after a few years gets old and it gets retired out of the system. So same with some of the content. If it doesn't get updated on a frequent enough basis, then it will get retired over time. And that retirement just removes it from the Living Atlas view. It's still available in ArcGIS Online. I'm going to jump into the oceans area just so we can get a quick look at some of the kinds of things that we're collecting with our user community. So we have lots of things around North America for planning, including drilling and permitting information to support that. We have lots of information on the seafloor mapping. This is the grid Arundel work that was done, and this is actually being shared as a vector layer that you can query and use to do analysis. Things like sea surface temperature, which are multi-dimensional data sets. And we have the 10-kilometer version now, but we're actually working on a higher resolution of that goes back, I think, to 1980s with NOAA. Then we have sort of seafloor bottom information, a lot of NOAA coastal reef watch information that's been curated in. So you can sort of start to see some examples of the kinds of things that the community is bringing in, and then Esri is also making available. One of those is actually Hicom. I'm guessing most of you are familiar with Hicom. The way we have this service set up is it's a data cube of all the variables from Hicom for the last 30 days and the next 7 days into the forecast. And it's being reported at 3-hour intervals. And I thought I would just jump into this quick app explorer, since it's hard to look at multi-dimensional in a single map. I'd bring it up here, and this is actually Hicom, and we're looking at September 24th. So we're looking a little bit into the history right now through this data cube. And you can see very quickly, just by changing the depth layer, we can look at the change in depth of the map and what the temperature is there. I've actually got temperature turned on. If I zoom into an area, wishing I was here instead of California today, I would be able to turn on things like the currents for that day. What are the prevailing currents and velocities? We can enable time. So right now we're looking at there. We can move forward and look out to this is today and moving out to tomorrow. So we can start to see the motion of these arrows as we're doing updates, and we could animate those. But this is all raw underlying data that's just being put through a user experience to really extract value and information quickly.
Yeah, two things I'll explain. One is this is a generic viewer that you can apply to any of these millions of data sets. The other characteristic is that one of the criteria for becoming a living atlas, and actually most of the items in ArcGIS Online, is that it's ready to use. So this isn't just raw data, it's been formulated in such a way that it's a service that you can mash up with other services, do analytics against them, or do interaction with them. You understand what I'm saying? It's not just like a big old library and then you got to figure out how to reformat it and reorganize it. Part of the process to put it into this environment is that it's ready to use. Sorry, Sean.
Yeah, no problem. And what I did here is I just clicked on the map. So rather than looking at it in 2D slices, we can look at a vertical component, or this is a profile of temperature at depth. So this is all just accessing that data cube on the fly. And we can change the time intervals, requery it, and find the next profile if we wanted. And we, of course, have that for temperature and salinity. And then they also have sea surface height, which is updated every 3 hours. So this just really becomes a really simple tool to sort of expose you to some of the multidimensional content. I think later on we'll see Orhun and Vinay are going to actually leverage this same cube to do some work and show you how to take advantage of it for analytics. That's just one of the layers in the Living Atlas today. I mentioned sea surface temperature. We have things around Argos and currents and salinity, but we're always looking to expand sort of the larger level, and in the oceans area, I think there's the work you've been doing will fit really well into adding more depth of these foundational content. So as we start looking at ways to work together, thinking about what content data sets that we should build to support you, which will also help our larger ocean community. The other thing in the Living Atlas, and Jack showed it right at the end of his talk, is this idea of vital signs. So this site is accessible from the Living Atlas page 2, and it's called Indicators of the Planet. And the goal here was to take some of these large foundational data sets and be able to summarize them, one into a single value that talks about change, and the other is to be able to let you dive in on a topic and explore it more through either an interactive map, a story map, or we have these things called Learn Lessons, which are really to support the GIS community in learning how to do analytics and analysis. So you see here what we've got is a series of what we call geocards. These cards are being updated all from different frequencies, and you can see different owners. So this one's actually coming from UNEP and NOAA. Here's a couple more from NOAA, OpenAQ, and actually the CI group, which Santa Barbara was working with on the Ocean Health Index. All these are in the card form, and they all update at a certain rate. So we're able to capture the update and look for deltas or changes. So in the case of Ocean Health Index, this is sort of more on an annual basis, but if we look at coral bleaching, we can say, look what's happened in the last week, and this is bringing information from NOAA. If I click on that card, I can actually now explore more about coral bleaching. So I can get a short description of what it is. I can link to NOAA's Coral Reef Watch. I can open an application that actually lets me explore different coral areas, and I can see the conditions here, move to that area and look at it. I can click on the map and get a lot of detail on what the current alert level is. And all this is being updated on the fly. And this is actually being hosted by NOAA, who's just putting it into the platform and doing these updates on a daily basis. If we continue down on this sort of card area, you can see there's a story map on endangered reefs and species. So I can open that up, and that becomes sort of more of a storyline of that Grid Arundel built, that really shows off the visualization and the storytelling experience once you build this content. And I can scroll through it, and Vern's going to do a demo of story maps, so I'm going to save a little of that for him. We also have links to videos. This is actually a video from NOAA. And then we have, for the GIS community, a set of learn lessons to learn how to do update coral in real time using Python. So these are all ways you can get access to it all from that one single geocard. And then we have lots of different topics like we were seeing on the front. Let me jump. Okay, so an area which I think some of you may be aware of, let me switch my screen around a little bit, is a project we did call the Ecological Marine Units. This is actually using NOAA's content from their World Ocean Atlas, which is updated about every 5 years. This is the 2013 version, and then we are processing their new 2018 version right now. But what we did is we took a multi-dimensional raster netcdf file and built it into what we would call ecologic areas. And these are taking the 6 areas that they collect around the physical and the chemical components of the ocean. So for each one of these locations, they've done a 50-year decadal average of temperature, salinity, oxygen levels, and then phosphate, silicate, and nitrate. And what we did is we actually did a k-means clustering process on that entire data set to create what turned into 37 distinct kinds of water in the ocean based on those parameters. And then what you're seeing here is this being contextualized in color. So it's also in 3D. So because this data set was in multiple dimensions, we could actually classify the water at depth and show its change in these ecologic zones of stratification. And if we click on any one of these, you can pop up, and what you're seeing here is the cluster name. So it's each one has a sort of unique number. It has a general name. This is what we call the human readable version of defining the place. So we characterize it as shallow, warm, normal salinity with moderate oxygen, low in nitrate, phosphate, and silicate. Then we also have a CMEX definition. This is more of the technical term name, and it's using the CMEX identification system that was built with NatureServe and a larger group of international people. But one of the things we learned from this is because we did this clustering process as a spatial component, we could actually tie confidence to this. So I'm going to switch this off, and I'm going to turn on a confidence map that actually shows 2 things. This is using the same cylinder concept, but what we've done is we've changed the size of the circle at each depth by the oxygen level, so we can start to see where low and high oxygen levels are. And then we've also added a transparency to this to show areas where it didn't fit well within those 37 different cluster groups. So we can start to define confidence by graying and sort of making invisible areas that didn't have good fits to any of the models. And then we can move around and we can look at different areas the same way, click on the map and get the same information. But since we are all oceans people here, we also know the ocean doesn't sort of sit still like this. So we started to look for a data set that would allow us to add long-term current flows. And this is the same information now attached with long-term current direction and flow information rates. And you can see what happens if, let me Zoom in over here. So we can now look at it in depth. We can see sort of the high level current direction, which is usually driven by the weather. We can also see the low underlying currents completely in the opposite direction here. And we can scan around and sort of see some examples of the different ways water flows at different depths. So this water column information has been really helpful from a using teaching community to really understand oceans. And this is an ongoing project. Keith, who's on the call here today, is actually working on this next iteration, so we can look at the next 5 years and now do comparisons. So what has significantly changed in the last 5 years are those in those boundary areas, and then we can start to look at long-term effects. Let's see. I think we'll just jump over here so we can keep moving. The everything I've shown you today is also available at a hub site that we're building right now. And this hub site actually acts as a focus place for all things ocean, and not just things in the Living Atlas, but also blogs and story maps and learn lessons about everything. So in this case, we can look at, here's some of the apps that we have available already, and these were really these user experiences in front of these live content data sets. We're currently working on a chlorophyll project with NOAA and really moving it into SDG 14.1 and creating a new standard for capturing and monitoring chlorophyll levels. So that's something that we can show you in a later story, but it really is sort of an interesting way of taking that raw information that's sitting in the Living Atlas, which is chlorophyll, sea surface temperature, and then bringing it together on the fly to merge and start answering questions similar to what Enrique was talking about earlier. Also, we have a series of blogs, and I'll share this link with everyone so you can just explore this on your own when you have time. Story maps, learn lessons.
I've got you covered in the chat, Sean.
Perfect, thank you. And then from our community, we actually have an annual conference each year, which is coming up soon. And then a series of the kind of projects that we've been working on. So I talked about the Hicom project, the chlorophyll work. We've also been doing some vessel traffic work within the U.S. boundaries with marine cadastre, and then some of these other projects that have taken off. The same way the vital signs of the planet, or these indicators, got built at our user conference this year. SDSN with Jeffrey Sachs, which is a UN focused group on SDGs, launched their own version of these cards that are focused very specifically on SDG goals, and they're going to be growing this over the next year or two. I think the work you guys are doing would be a perfect addition to this kind of work for them to really start to define some of these goal areas. But I think from here, I should probably hand it over to Bern and let him talk about story maps.
Just before we go there, do you guys have any questions about the Living Atlas? Or
yeah, I have a couple. Thanks, Sean, and it's good to see you again. We met in Cambridge last year. It's good to see you again.
Good to see you.
I had a question. I saw that you guys have data from Global Forest Watch, and I was wondering if you are planning on doing the same with Global Fishing Watch, given that it's kind of like the main data of human impacts on the ocean. It's them, and yeah, I was hoping if you could speak a little bit more about if you guys have engaged with them at all, or if not, then any other threats or impacts layers that you're exploring to incorporate.
No, I think that is one of the layers that we've considered as a way to bring in that multidimensional data set, and they are on my radar in our backlog. So it is something we're very interested in, and I know it's something that Enrique was mentioning that he uses quite a bit in the work you've been doing. So I think it'd be great to collaborate on that. And sort of what we usually do is we don't just throw the content in until we really have someone who's really focused on the right ways to use it, because we're not the experts. So this is the perfect group to help us define what would the data model look like to really be effective for your analysis. So yeah, I think this would be a perfect time for that.
And I think just to add to that, I totally agree. I think the closest we've come to that, Juan, has been with Ben Halpern at NCEAS and his original data from his famous science paper on human impacts in the ocean. We've got that as a web service in the living, no, it's in ArcGIS Online. I don't think it's in the Living Atlas, Sean, but anyway.
Yeah.
Yeah, our strong preference is actually to leave the data right where it is and integrate it into ArcGIS Online and Living Atlas as a service. So it's a reference point that can be brought in from like NOAA's weather service. We don't copy NOAA's data or even the Landsat data. We bring it in as a service, and then our users can mash it up and integrate it and do analytics on it.
And also, Juan, one of the things we've been doing probably since last year when we met is, you know, most of these data sets are stood up as these server environments behind the scenes. So they do require more overhead to manage. We started a private beta of a new online way of serving raster data, multidimensional data set right in ArcGIS Online through a cloud environment that don't require you to set up these server environments. And I think that kind of content that you're building within your team, it would be so easy with this new platform technology just to push your result data sets up and share those without having to create a new overhead for yourself.
And Sean, that would support this idea that Enric talked about, is going to a country from the cloud, being able to run the analytics dynamically, like right in front of a prime minister, using that raster analytics plus any other layers that are there.
Yes.
Yeah, very, very exciting stuff, definitely. And as I'm thinking about how can we link our work with what you guys are doing, so the model that produces the maps that Enrique showed, for example, the biodiversity one has maybe about 6,000 rasters behind it. So would you like I could see it as we could put the final product on the Living Atlas, but if we wanted to have the flexibility to run the model on the fly for a country, then we would need to host all those 7,000 rasters somewhere.
Yes.
And is that something that you think you just as a service with where our data is, or bring ingested into the system?
You could either upload the rasters into the cloud, ArcGIS on cloud, and run the analytics dynamically right there, or you could keep it on wherever you have it right now and just access it as a service. But I think the idea of putting it right into our environment would be exciting, because it would allow us to mash it up with other sorts of analytic raster services dynamically.
Yeah, one we're actually working with the Half Earth team right now, and they have around 20,000 species range layers that we have built into a data cube. And we do two different ways. One, we do summarization into taxa groups, just because it's sort of the responsible thing and simplifies your workflows for, you know, general use. But then that huge data cube can still be used dynamically on the fly, just like I was showing you the Hicom data where I clicked on it and it was showing you the depth. That could have been, you know, the dimensions of each one of those range data, and did it intersect or not intersect. And so we've been working on that also on a land-based project that's at 1 kilometer. So I think the 6,000 would be right in our wheelhouse.
This is a really helpful conversation. I just want to kind of echo some things back that you both said, Jack and Sean, that are really exciting to us about this. You know, I think we all know that behind a map, there is so much there, and that for the maps we've produced in particular, you know, I would argue that those 6,000 rasters that Juan mentioned are probably the least interesting part of this effort. It's actually the modeling framework that does the conservation prioritization, which could be amenable to X thousand more layers or fewer or different layers. And so I think the thing that is exciting in seeing this just menu of possibilities you've put in front of us, Sean, is that there's better data in what you have that's updated more regularly than what we used. And that data landscape is constantly changing and improving. And so that's something where for these types of kind of bespoke analyses for a marine spatial planning effort in a particular place, I think just integrating the analytical framework that we've developed, which I know ArcGIS already does for certain frameworks like MarkSan and others, and ours is just kind of a riff on those that we think is more flexible and provides kind of more user opportunity.
Yeah.
But really being able to tap into, like the infinite underlying data layers that can speak to those objectives that we've called out in biodiversity, in food provisioning, in carbon, and potentially others that could actually be accommodated in the analytical framework we've created. And so I think that's really where like kind of the magic and all of this would happen is just in tapping into that base.
Yeah, when you were saying that, it made me think of the indicators. Is what's really happening here is there is a large, big volume of really important data behind the scenes that's been collected, but the summarization that's happening here is what makes it easier for people to understand. And in this case, we actually use a hosted Python notebook behind the scenes, touching that live data on the fly and then updating it at whatever the interval the content changes. So it's really made our team think a lot more about, when we think about serving content in our platform today, the first thing that comes into mind is how often can we update it and how consistently can we get it updated? So there becomes a cycle, because as soon as that cycle happens, your analytics can change on the fly as new information shows up. And that's amazingly powerful to show change, not just the condition.